Well, let's start with a challenge for infrastructure architects, because when I started my research in 2005, the only things we got when talking about infrastructure were technical designs. And when you talk about technical designs, I have, well, a very abstract version or form of a technical design here. Well, all the time when talking about infrastructure, people are talking about boxes and wires. Because infrastructure, when you break down the kind of and the type of components that are used are often boxes, platforms like server platforms, client platforms, and also wires, because you also have some networking and some data transport between these boxes, and of course you have storage systems which are boxes as well. So from a component and from a technical perspective, for many people, many stakeholders, it doesn't mean anything. So when you deal with infrastructure from a technical perspective, it's only meaningful to specialists, and even specialists amongst each other differ from views, because if you talk to a networking professional, you get another view on infrastructure than when you, for example, talk with an Exchange specialist or a Microsoft Server specialist. And because it's a technical domain, it's very close to the others, to the rest of the world. So it's very hard from this perspective to have alignment with the business. And when you talk about infrastructure in technical terms, well, people are not interested or are just not aware of things. Also, for other domains, it's very hard to perceive what infrastructure is, how it can be of help, and how it cooperates with application components, application functions, business processes, data models, etc. There are at present no real standards for technical designs, because when you see what is on the market when talking about technical designs in the infrastructure world, it's very much vendor driven. So Microsoft does have its own standards, Cisco does have its own standards, Oracle does have its own standards, and often they are from the perspective of the products and not the perspective of the functionality. So when trying to create an infrastructure landscape and maintain it and develop it, it's very hard from that perspective to keep it coherent. And we see a lot of times that the same functionality is implemented in several ways and in different ways that creates unnecessary redundancy, which is costly, of course, but also creates a lot of maintenance and administration trouble. So the result of all this, is that whether the development time is taking a very long time, because people are struggling with the requirements that are relevant, and then translate these requirements into real solutions. Or, for example, infrastructure is the last phase in a project which needs to be delivered very, very fast, and therefore delivers hasty stitch work. So, for example, a project needs some hosting. All of a sudden, the hosting capacity is put there, and it should work immediately, and it's not considered well enough, and it does not integrate with other parts of the infrastructure. Well, and then what's infrastructure actually, and is it important? Because some people from the business tend to say that, well, why bother with infrastructure, because it's only a collection of boxes and wires, so why do we bother anyway? So we have to look into infrastructure and the essence of infrastructure for just a few minutes. Well, first of all, and maybe I think everybody knows it, but infrastructure is the foundation of IT. Without infrastructure, there will be no automation, and with no automation, most businesses will fail. So at least it's the foundation of IT. But it's also an agility enabler, because if you have a flexible infrastructure that is adaptable, you can implement new business processes and new activities and new applications more quickly than when you have a scattered infrastructure landscape. And the last part is also important, because it's the connection point between the digital world and the real world, because infrastructure is delivering the interface between human users and digital systems. And the working space is a very important part of infrastructure that is also considered by end users to be the face of IT. So if you deliver a good working space to your people, then people have a lot more confidence in the IT as a whole than when it is a crappy workspace. So these are three reasons why infrastructure is really important for a company, and because it's not only a platform but also a lot more. Because if you see the content meta model of TOGAF, you see that infrastructure is limited to the platform that is used by applications. But for example, infrastructure delivers digital access portals. It provides all kinds of means of data storage, from databases to loosely coupled file systems to really to unstructured physical storage, and all kinds of replication between those things. It handles communications, both from human beings as well as from systems, and therefore it's also the heart and the core of the information household, I think, and especially when you have a service-oriented landscape, or when you are moving towards the cloud. These kind of services and these kind of infrastructure facilities become even more important. If you have a service-oriented architecture, infrastructure is the thing that keeps things going. So it also delivers orchestration. And last but not least, infrastructure is also for a large part, apart from security processes, the real implementation of security enforcement is done by infrastructure facilities. So, and we all know that the threats from the outside world are emerging and are getting bigger every day. So, and it's also delivering attention, because we want to have a very common and very useful infrastructure on one hand, but it also needs to be very secure. So that makes our design task even more difficult. Okay, but how to put the organization in control? Because now we have seen that it's important, but how can we align it with the business? I've seen in the Q&A window that's one of the questions being asked. So how can we put the organization in control? I also see a Q&A question about what is infrastructure from a definition point of view, and I would say, well, I've shown you a few examples, but a common definition could be that infrastructure delivers all kinds of facilities, even some sort of ecosystem, if you want to say so, all kinds of facilities that are supportive by nature. So they support other processes, other applications, other things. So infrastructure is supportive. It's a utility, a common utility that is used by many users, applications, processes, activities. I have to add something else to this definition, because in the modern IT, we see that also common applications like telephony or mail are also strongly being considered as infrastructure. In most companies, telephony, mail, but also messaging systems between applications are considered to be infrastructure. So maybe we cannot draw a very, very clear line, but one could say that infrastructure does not provide money to a company by itself. It's only bringing worth to a company if it's being used by other things. So you can also compare it to landscape. You know, every landscape has facilities that are needed to make daily life possible. So you have roads, you have parking places, you have light poles. Underneath the ground, we find gas pipes, electrical lines, all kinds of communication wires. We have a source system. So in a normal landscape, you also have a lot of infrastructure that is supporting daily life, and it's supporting all kinds of usage. And that's exactly how infrastructure in a digital world works. It's like some sort of landscape planning. So this comparison is in two ways important, because on one hand, landscape planning means that you have to do it to enable huge transitions. So you have to prepare an infrastructure landscape to be able to accommodate huge business changes, or, for example, new applications. And on the other hand, the comparison also shows that it can be a very painful process to change a landscape, because if you tear down 4 houses to build a skyscraper, you have a lot of trouble. For example, you have to deal with parking space, or you have to deal with the capacity of the road or the capacity of the sewer systems. So you have to adapt the landscape before you actually introduce the large change. So you have to plan it in front of you have to plan the infrastructure in front of other transitions. So that's very important about the infrastructure architecture. It's always, you should always be one pace ahead of the rest of change. But then we come into the following problem, because when we talk about infrastructure with an end user is always an end user finds it very difficult to express requirements, because an end user, when it comes down to infrastructure, is talking about appearance, and you can compare it with a car. When an end user is talking about the car, it's about how fast it goes, or how well it behaves in curves, or how well it does impress women. And people are not so concerned with other kinds of the heart of the functionality of the car. Maybe because that's, for most people, it's implicitly known. On the other hand, the engineer who is going to build the car is not interested in the appearance, but is interested in the construction. So he knows a lot of how things are constructed, what kind of engines are used, what kind of brakes are used, what kind of materials are being used. So as an architect, we have to reconcile these two worlds, especially in the infrastructure corner of our profession. We need to reconciliate the end user with the engineer, and for that purpose, we need models. We need models to bridge that gap. Well, we can say a lot about models and theory on models, but the most important thing is that, of course, a model is only is presenting a view. It's actually leaving a lot of details out, and only showing the things that you want to showing the only things that are relevant for discussion. And when it comes down to infrastructure architecture, our main point is that when we are talking about infrastructure with all kinds of stakeholders, the main important thing we want to talk about is functionality. So, of course, maybe we will not use ArchiMate drawings to communicate with all of our stakeholders, but probably we will use several models to communicate the functionality that we will provide by means of the infrastructure. So end users in the end are interested in the functionality of the infrastructure and not so much in the construction. And I think that's the main point of our approach, that we try to express functionality of infrastructure instead of construction, and in that way make it more accessible for other stakeholders who have no technical specialism or no technical understanding, and being able to have a debate, to have a discourse about what should be provided by the infrastructure. Well, we do that with 3 different ingredients. Of course, we need a vocabulary, because if you want to talk about infrastructure in a functional way, you need a vocabulary. You need words to express the functionality of infrastructure. And traditionally, the vocabulary being used in the infrastructure domain has a technical nature. So we had to discover and to define new terms in order to be able to discuss things in a functional way. We put that because if you find words, you want to express things with these words, and then you also need a grammar. So we adopted ArchiMate as the grammar, providing us concepts and relations that were useful to express our functional infrastructure models. And last but not least, we also adapted a workflow that provides us with a structured step-by-step way of working. And it was inspired by Professor Dr. Blauw, who was from the Netherlands and was a very distinguished engineer by IBM, who really well described his design approach, which was very helpful to us. So, well, let's just check this in. I'm going now. For every ingredient will be checked in a little bit more detail now. Well, first of all, the vocabulary. And I see there's a typo in the slide. We started with the same picture as I showed you earlier. So we have OIAm is also a result of a large community with a lot of companies involved. And we started to see to all these infrastructure landscapes from a new perspective. So we still had these boxes and we still had those wires, but what we tried to do was to define the functionality that was provided by the boxes and the wires. So we said, hey, here we have a bunch of servers, and they have the role of an application engine. So they support and carry out an application. Then we have a set of boxes that are presenting the data and the information of the application, for example, by means of a web GUI to an end user. And we call that a presentation engine. But you can also see this one form of a presentation engine, because you also have, for example, presentation engines that make it possible to print things on paper, or have some other sort of user interface. We also identified, for example, a scheduling function in every landscape. We also considered that there was an authentication authorization service present. And when we looked into authentication and authorization, and I will show you that later in greater detail, we realized that authentication and authorization was not a single function, but that actually it was an aggregation of several functions working tightly together. So we started to find some structures in these landscapes that were very predictable from a general point of view. So if you look to every single infrastructure landscape, you can identify in every landscape the same functions, but they also all the functions have the same sort of relationships between each other. So if you strip technical details from it, if you strip the construction from it, if you strip the vendors, the products from it, and you purely look into functionality, every single infrastructure will start to look the same. And here, for example, data management is another function. So we made some sort of dictionary. We created a dictionary of all these words and put them into a repository. And I will also show you later in some slides from here that you will be presented with an URL to an OIAm community repository which contains all these words. Also together with every word has its own definition and its description. And not only its own description, but I will show you later that also we documented these patterns. So you can use these patterns at your own disposal. Then the grammar. I hope most of you have heard of ArchiMate and know a little bit about what ArchiMate is all about. And the main concepts are, of course, that the thing is that you have three layers: a business layer, an application layer, and a technology layer. And you also have three columns, which in the middle you have the behavior, and then you have the active structure which carries out the behavior, and also the passive structure, and that's what the behavior is carried on about. And you have, for example, the business layer. You have a business process that is carried out by business roles, which are designated to business actors, and these business processes are carried out on business products, contracts, business objects, etc. The same on the application layer, and the same also on the technology layer. And the nice thing is that already in ArchiMate, you have elements that are very suitable for modeling infrastructure functionality, especially in 2.0, because in ArchiMate 2.0, the function also was added to infrastructure. So you have the infrastructure service which provides external behavior, and then it's realized by internal behavior by means of infrastructure functions. And infrastructure functions, that concept is exactly the concept that is used by modeling infrastructure from a functional perspective. So what OIAm does is providing the words and the patterns to define the infrastructure function. So it provides content together with it provides content that is combined with the concepts of ArchiMate. And that's I think the behavior column is the column that is central to the way we model infrastructures. And of course, when the behavior is being constructed and modeled, when the behavior is being modeled, functionality is being modeled, you can also assign active structure to it. So, for example, if you have an application engine, you can assign a node or even some system software and device to it, but the starting point is the functionality, and then you can assign the other concepts to it. So these are the core elements that we use: functions and aggregate functions. And aggregate functions are the patterns we were talking about, and they provide and they realize the services. We can we also use very often the requirement element from ArchiMate, because with that we can express specifications and requirements regarding functionality. Of course, we can use location as a concept, for example, because the variance of different functions can, in infrastructure, the same function can be differentiated in several variants because of the location it's put in. For example, if you have network access in a data center, it's completely different than network access in an office. So location can also be a very useful concept in ArchiMate to express things in models. An artifact can be used as an additional concept. Interface and node and communication path. These are the core concepts that we use, and the nodes are used to assign, for example, specifications for technical designers into our models. Then the last part is the workflow, which is also, well, it's I think in one way this is not rocket science, because there are more methods that distinguish between functional design, technical design, and realization as different steps. And also within the TOGAF ADM phases, like B, C, and D, you can, when you carry out these phases, you can also use this workflow. So starting out with functional design, then creating a technical design, and then start with realization of the design. But the thing is that there is another concept that you can plot on it. So not only the phases, but also the movements you make in every phase. So we discovered that if you know an archetype, it's very easy to define the implementation. So the patterns we found in these landscapes, you can consider those as archetypes, which can be used to model the specific implementation which is needed in a specific situation. And I will show you with an example how that works. So take, for example, the archetype of an analog clock. So the function of an analog clock is indicating time, so that's the function, and its very abstract construction is a dial and at least two hands. So if you want to use this concept in a real life situation, for example on a train station, you can plot this concept, this archetype, in the situation you need to architect. And one of the main requirements for a train station clock is that all clocks are in sync. So when thinking about clocks in the context of train stations, you start to discover the requirements. The main requirements will be that you are in sync, and then the real architecture work starts. So how the architect's problem is, how can we provide guidelines to the technical designer in order to make sure that he does the right things to put all train station clocks in sync. And one of the specifications that we could, for example, put handouts to the technical designer could be use a very specific, precise clockwork. But that would be very expensive in a situation where you have a lot of where you have a lot of train station clocks. So another solution direction could be that you say we have to synchronize, for example, by means of a clock network, and it means that we have to synchronize it every minute. Well, in the Netherlands that's the case. So in the Netherlands, the architect has specified that every clock is synchronized by means of a clock network and a mother clock, and that every minute the clocks are synchronized. And we can tell that by the behavior of the clock, because the seconds hand is the specification for the seconds hand is that the turnaround time is less than 1 minute. This allows the seconds hand to wait a couple of seconds, to wait for the signaling, the synchronization signaling, and then carry on. So this is a very cheap way to keep every clock synchronized per minute. So we hand it over to the technical designer, and the technical designer also has some archetypal concepts to build clocks. He translates it into a technical design for a platform clock. Well, from the design, the actual implementation design of the platform clock, the standard components are being derived, so we can order standard products from all kinds of vendors, and then construct the actual platform clocks on the actual platforms. So this works very well. This workflow works very well for infrastructure, but I'm sure it also works for other domains. So it will also work for application development, for example. The power of it is that you depart from an archetype that you know already, and then translate it into an implementation that's relevant to its context. But of course, you have to know your archetypes, and that's where the concept of OIAm is coming in, because we have a repository, the Open Infrastructure Architecture repository, and you can check it out for yourself, because it contains about 20 generic patterns that are the archetypes of the services that are present within an infrastructure landscape. These patterns are being crafted and discovered by a community of infrastructure architects, most of them residing in the Netherlands, but from a lot of companies, mostly large companies. And it provides other architects a quick start for modeling. So you can use these patterns and start modeling for yourself. Another thing is that it's also these models, these generic models, are very, very well suited for requirement management approaches and inventories. I will show you later with a real-life example. Here we have an example of such a service archetype. So we have here authentication and authorization, and within authentication and authorization we have identity validation as a function, which needs an identity store where identities accounts are stored together with attributes like credentials, but also, for example, group memberships and stuff like that. And this function is also used by permission validation, and permission validation is an infrastructure function that checks if someone who needs, for example, to access a file has the right to do so, or someone wants to delete a file and it needs to be checked against a permission register if someone is entitled to perform that action. And well, why is there, for example, a relationship between the identity store and permission validation? Well, if you want to carry out role-based access control or role-based permission validation, then you need a connection with the identity store functionality in order to check if someone who is claiming the right to perform a certain action is, for example, well, maybe not every person is listed in the permission register, but, for example, groups are listed in the permission register, and then the permission validation function needs to check the identity store to see if the person who is claiming the action is currently and actually a member of the group that has the right permission. So this is for a small example. This is also a small example for how fundamentally some infrastructure functionality works and how relationships between several functions are relevant. We have about 20 distinct patterns in our repository, and I think they cover about 95% of the infrastructure landscape. we also are able to combine those patterns if needed. So very often in my architecture work, I combine file storage with raw storage, for example. That enables me to have a single model to display this the functionality needed by the client. I see some other questions about generic patterns. Well, I think we focused on infrastructure. So what we have here are infrastructure patterns. But of course, the idea of patterns is not limited to infrastructure. You can discover patterns in every area. But the most important thing is and I should go back to the workflow. You need to be aware of the fact that on every design level you can distinguish patterns. Let's check that for. Let's see if I can go back. Oh yeah, yes, here we go. So we have patterns on a functional level. We also have patterns on a technical design level, and we also have some sort of patterns on the realization level, because we have, well, for example, if you see product catalogs, every vendor has its own catalog, but catalogs between vendors are quite similar to each other, so they make sort of the same products. So even on the realization level, you see the same patterns. So, but you must be aware of the level of the pattern you're talking about. And with OIAm, we focused on the functional patterns. Okay. Before I go to the takeaways, I would like to show to you a little bit how we use these models, these generic models, which are also, we also brought these models into a tool, and I'm going to share the tool with you. It's BusyDesign Architect. I hope this works now. I hope, yeah. It's starting to share. Yes, so we have a repository and all the generic patterns that are present, for example, application hosting, all the generic patterns that are present in the online repository, which, by the way, is freely accessible, and everything we discover we publish under a Creative Commons license. So we make sure it remains. Because it's from a community, it stays in that way. It stays it stays in the possession of the community. We also saw let's see, we had the identity and permission management and authentication authorization thing. Yeah, here it is. So here we have this model, and for example, from this generic model, I can create now a new view. And I can say, for example, I want to create authentication and authorization for an action website. So at least what I want to know, I have permission validation. And here I can make, for example, I say, what if I have an action website, what kind of permission validation will I want to use? I can, for example, use a permission validation for the action website by means of a coupon code. So in that case, I would not need the identity of the person who is accessing the action website. I only know people only need to fill in a coupon code on entry of the website, and if they have the valid coupon code, they will be able to log on. So in order to validate the coupon code, I need a permission register, which holds the permission register coupon codes, which holds all the valid coupons, or at least the rules that are used to identify the valid coupons. So I have a use by relationship. I have to reassign it. So this simple model can be enough to aggregate the authorization part of the action website. But let's say, so we can aggregate it. I have to reverse that as well. Okay, and then I can now put these into these boxes. So but when I'm talking with the client who wants to realize this action website, the client can say, yeah, okay, this is a very good idea to check permissions of customers, but I also want to have other people log in, for example, maintenance personnel or administrators. So I also need permission validation for administrators. So we use the pattern. Say I have the permission validation function. But now it's for administration purposes. I also have the permission internal users. But now I need the identity store to check if an internal user is actually an administrator, and of course then I also need the identity validation function. So if an administrator logs on, he claims to be himself. Okay, so this will be used by that. And that way the identity store can be used to validate the permission of an administrator that he wants to perform a certain action from his role as an administrator. And I can also assign it to, of course, and I'm not going to finish this because it will take too much time, but I can assign this to and I can aggregate these functions. I will just do one. All these functions to this function, and together they will realize the authentication and authorization service for the action website. So I can do that. And then realize. Okay, I hope you're still with me. And I will stop sharing now. But that's the way how we translate these generic patterns. How we use this generic patterns to create specific patterns, and in this way we can use these patterns to ask questions to clients. For example, if they want to authenticate people, how are they doing that, and what kind of artifacts are needed for that, and stuff like that. So I cannot go into cannot go into more detail now because time is limited. But you can of course then start asking customers, for example, when it comes down to identity validation, how many factor authentication is needed, 1 factor, 2 factor, things like that. What kind of artifacts are relevant for that? Typed passwords, or also tokens, or certificates, things like that. So, okay, then let's see how we can. I think I now can get to the most important takeaways. And Pierre Boivin is asking what drawing application is Business Design Architect, and I see Janak Shah ask a question. The 3-4 main steps of infrastructure architecture needs to be summarized. I think I will come to that when I finish this. So, the main point here, if you want to use some of the findings of OIAm together with TOGAF, you can start by using the infrastructure functions that we have defined when creating your architecture building blocks. So the patterns and the functions are very well suited to create the ABBs that are described by TOGAF. So at least for the D phase of the ADM cycle, you can use at least the vocabulary to be able to have a functional definition of the required infrastructure functionality. Of course, you can, within these cycles, you can also use the workflow we defined, so that you say, well, we are going to design our infrastructure starting from a functional perspective, and then translate it into technical requirements, and from the technical requirements, select the right technical components. And then you start to work from the architecture continuum into the solution continuum. So I think it is seamlessly fitting into a TOGAF approach and provides the vocabulary and the patterns needed to create the ABBs and also do the requirements inventory that is tied to it. Then, of course, it's 100% integrated with ArchiMate, so you can create infrastructure models that are formulated in such a way that you can provide the services that are needed by applications, so you can define the services that are needed by applications and business processes. And then the next thing, and I will answer the question from Venkat soon. The next thing is, an important point I want to make is that in order to do the architecture work, carry out the architecture work, is start from functionality, because that is what stakeholders are interested in. Stakeholders are not interested in infrastructure construction. They mostly are not interested in the technical details of it or the vendors involved. Most stakeholders, especially end users and businesses, are interested in infrastructure functionality, not in construction. So this provides a means by starting with functionality and then translate it into requirements and into guidelines that steer the development of the construction and the structure part. And well, I've done research since 2005, and it took us quite a long time to define this vocabulary. But now we have it. We use it an awful lot, because it provides us a lot of. We gain a lot of speed by having this vocabulary, and I think that it also applies in other domains, if not already being discovered or carried out. So if you have a clear vocabulary that you can share within a community of, for example, business architects or information architects, it really speeds up the work of modeling. So, but of course, I'm only an infrastructure architect, so I didn't try it for other domains. A little bit I tried it together with colleagues on the application level, which also worked tremendously, but we are still looking for generic vocabulary there. But I think it should work well on other levels as well. So, well, with OIAm, as I said, it's providing a workflow, which is structuring the design process greatly. It is providing you vocabulary, and it's using ArchiMate as a standard grammar to make models. Of course, these models are a means to achieve other things. So, for example, you have seen the landscape overview with the several services. This overview is really a great help in infrastructure landscape planning. But of course, you can, as I showed you, you can also make a structured requirement analysis, because you can talk with customers and with end users and with stakeholders about functionality. And because of talking in terms that are well understood by other stakeholders, which are not technical by nature, also provides a lot of support in the organization. And it also means that you can obtain control over the supply side. We have seen very nice tenders where we only specified functionality and then put it in an RFP, so that vendors were able to deliver their own technical design, and that really was had great results, because it gave some freedom on the side of the vendor, in order to provide a solution that the vendor believed in, and it also was very specific and clear about the functionality needed by the user, by the organization. Actually, also a question of Douglas Steele. But if you want to find the vocabulary, you have to click on infrastructure architecture artifacts, and then under building blocks you can find the vocabulary, and under pattern types you can find the services. We have already started the work on a new repository, and in the new repository this will be under functions and aggregate functions. But we used to we started by defining building blocks and pattern types. But the thing is that in the world, the word building blocks is now used for all kinds of components. So after we adopted ArchiMate, we decided that we should adhere more to ArchiMate and then use the term functions instead. In the current repository, it's still called building blocks. Okay. Then I see some other questions, but I'm not sure if I am able to answer all of them. Well, of course, BizDesign is just a few slides on BizDesign and where to find the tool. Well, the tool I just used was BizDesign Architect. It can be downloaded from the bizdesign.com website. You can download the free trial if you like. There were some questions about that. So if you go to www.bizdesign.com, you will be able to download the tool and to check it for yourself. Of course, BizDesign can help companies and organizations to with workshops and consultancy services to put it into practice in your own organization, and to try to get a talk of ArchiMate, OIAm, and other approaches. And of course, well, we provide some training as well, and I will put into, well, I think when answering some questions, I will put this slide in front of you, so that you have some URLs that you can check out, and I can see if I'm going to check if I can some other questions. I see a question of Victor Maduro. How do you map ABB and SBB? Well, I think the ABB can be mapped on the functional design phase, which I showed in the workflow. And the SBB will be more the domain of the technical design. So you can see that the ABB, we create ABBs by means of OIAm, and then on the ABB, it's possible, for example, to assign it to a node, and the node, probably even being more specific, modeled more specific by means of system software or devices, is the bridge between the ABB and the SBB. So if I go back to the model, which I created, I said I'm not sure. I have to share it again. Just a second. I hope it's being shared now. So for example, I can assign a node to, well, let's say that the internal users are being let's go. I can create a node, and I'm sorry that I still have this application in Dutch because it's also this application can also be easily turned into English. Let's say, for example, this is Microsoft Active Directory, or maybe any directory, and I can assign this node to, for example, this function. I think this will be the bridge to your SVB, and you can even put, for example, some system software to it, like the Microsoft Active Directory. And I tend to use the aggregation relation. I prefer it over the composition relation, because in infrastructure you want to be able to use some components at several places in your modeling package. So a composite relationship would be too strong to do so. And I think, well, this is actually the ABB, or part of the ABB, and this is the bridge between ABB and SVB, and this is the starting point for where you can craft the solution building block from. So I hope that does answer that question, and I'm going to stop sharing.